Chapter 10, Chapter Test, Question 9. So this is the last question. So let's have a look at it together. The figure shows a vessel in the shape of an inverted right circular cone. It just means an upside down cone, and the vessel contains some milk. So now they ask you to find the depth of the milk. So you can see that in the questions. You might find that it doesn't have a lot of information, but please do not use the information they gave you in part B and C to do your part A, because you're not supposed to use anything after your part A to do the questions. So all we can do is look at the information they give you in that diagram. So you can see that the vessel have a radius of 12, and then they give you the height of 6, but this is just a part of the height of the vessel. It's not the full height. And then they give you the radius of this milk here. So you can see that the shape of this milk here is actually similar shape as your whole vessel. Both of them are cone. So therefore, with similar shapes, you know that you can use that relationship to find the depth of the milk. So we can always draw it out. So QCV, you can see it is this little part here. So I just cut it out to draw it here. And then the milk is actually VPA. And you can see that they are similar triangles. So what you have learned in Form 2, your similar triangles and congruent triangle, for similar triangles, you can always use the ratio of the length to help you to find what information you want. So the ratio of the length should be the same. So you can see I let HCM be the depth of the milk. So it's very important you always let the unknown so that you know what you're talking about, because some of you didn't let it and you thought you've got the answer, but that is not the final answer, but because you forgot what is that unknown meaning. So here we have the triangle VPA similar to triangle VQC with the recent AAA. So with that, you can say that the ratio VP, so when we look at it, VP compare with VQ, and should equals to the ratio. So we look at the same triangle first. So PA, we have this information PA, so when we compare with QC. So PA, we put it in the numerator, QC, we put it in denominator. VP here is H, and then VQ, a lot of you just write 6. Again, this is H plus 6. You write 6 because you didn't really draw the diagram on the side. So when you look at this diagram, it is a little bit confusing. So always have a habit to draw the diagram out yourself. So draw it out on the side so you can see it clearly. And then there's another careless mistake is you forgot that the 4 has 2 times inside the brackets for both of the letters or the numbers. So therefore you have 8. H equals 24, H is 3. So therefore the depth of the milk is 3 cm. A lot of you find it you use a similar way, but why is your answer wrong? Because you find 9 cm, but 9 cm is actually QV. You forgot to minus QP in order to get the depth of the milk. So therefore, that's why I said it's very important to state what is your unknown stands for. So therefore, you won't confuse later on. And then part B, it says 112 pi cm cube of milk is now poured into the vessel without overflowing, meaning that no milk is spilling out the vessels, and then find new depth of the milk. So in this case, we have more milk poured into the vessel. And when it's poured into there, you can see that the amount of milk you pour into there, 112 pi cm cube, it is actually a frustum, the shape of a frustum. So then you will quickly think about, oh, maybe I can find the the depth of the milk by using the frustum, and for frustum, volume of frustum, you have to use the big cone minus the small cone. The volume of the big cone minus the volume of small cone. But the thing is, the volume of the big cone, you can't find it because we don't know what is the radius of the big cone. And the height here, we don't have it yet. But when you look at it, if we look at this big cone, it is actually similar shape as this small one. So this big cone is the new milk, and this one is the original milk you have got there. So here, when it says 112, be careful. 112 is just the frustum. So if you add the original, then it will become this big cone here, the volume. So since we don't have a lot of information, we won't use the formula for frustum to find the new depth of the milk. But as you can see, I said that this is a similar shape. So this too is a similar shape. So therefore, we can actually use the relationship between the volume, so the new volume and the old volume. So volume of the new one, if I compare with the volume of the old one in a ratio, then we can say that the depth of the new cone, the new milk, compared with the depth of the original milk, we can find it because we have this information here, and we have this information here. So the original volume, do we have the information to our original volume? We actually have, because original volume of the milk is equals, so here is a cone, so this is a cone shape, so half 1/3 times pi times the radius, which is 4 square, times the depth of it. The original depth of this milk is 3, which you got it from your part A, is 16 pi cm cube. So now we have all this free information, so we can find the depth of the new depth of the milk. So new volume of milk compared with the old volume of milk is equals to the new depth of milk and to the original depth of milk. So there's a common mistake here that a lot of you know is using the relationship between ratio, but you didn't put cube here, you put square. But again, remember, for volume and depth, we use cube. And then there's another problem here. 112 pi is this little frustum here. And then you just use 112 as your new volume, which you want to compare with the old volume of milk. You cannot compare it like that because one of them is a frustum, one of them is a cone shape. Only similar shape can compare. So therefore, in order to compare, you have to use the whole area here, the whole volume here, whole volume of the milk. So now the whole volume of the milk is your 112 pi, which is the frustum, adding the original volume, the little cone there, compare with the old volume, which is the little cone, and the new depth is what you want, new depth. So let's use an unknown here, y. And the original depth is 3, which you got in your part A. So let y cm be the new depth. So now you have 8 if you solve the left hand side. and then you have this, so y equals 6. So therefore the new depth of milk is 6 cm. So the only thing you have to be careful is 112 is only talking about this part, and this part is a frustum. Again, you cannot compare it using the ratio because frustum is not a similar shape as the cone. You can only compare it if it is a similar shape. So some of you might ask, how do I know I have to use this way? Always look at what information they give you. If you don't have enough information, then you can't use the formula of frustum to find the depth. Then look at what information you have, because we have the new depth. We want to find a new depth. We have the original depth, we have the new volume, old volume. Then you know you have to use this to help you. So and then part C, it says find the area of the dry surface. So in part B, we add some milk already. So this part here, the whole part is wet surface. And when we talk about the dry surface, we know that we're talking about the curved surface area. Why is that? Because this top here is wet as well. So only the surrounding part, which is the curved surface, is dry. So in order to find this, again, we have to look at what information we have. So we know that curved surface area of a vessel. So we can write on the sides. So just to remind us, curved surface area. So for curved surface area, for a vessel, which is a cone, we know is pi r L. But this pink area, the dry area, is not a cone, it's a frustum again. It's the top part of this cone here. But again, we don't have a lot of information about this part because again, we do not know what is the radius. And we do not know what is this here. So in order to do this, we know that the area of this dry surface is actually equals to, so write down again, so area of the dry surface is equals to the curved surface area of the whole vessel, so this whole vessel, minus the wet part, the wet surface, so our area. Wet surface inside the vessel. So we know that, and by looking at it, do we have the curved surface area of vessel? So as we said, let's use another color. So as we said, this one here, we need pi r L, but what is our L? We don't have the L yet. So we have to find this L here. So this here, we look at the information, we got this radius of this vessel, and the height, do we have the height of it? Yes, we have the height of it. So let's draw it out on the side. So height, again, 6 is given, and this here is the little dry one, 3 cm. You got it from your part A, so therefore we can start writing this out. So let's find the slant height first. Slant height, we can find it using Pythagoras theorem. So 12 was given, and VQ again is not just 6, but 6 plus 3, and therefore you should have 15 cm. And now you can find the curved surface area of the vessel. So curved surface area of the vessel is your pi RL. So pi RL here is 12 and 15. So 180 pi cm square. Make sure you have the right unit. And then we will let A cm square be the area of the wet surface. So in order to find the area of the wet surface, we can see we do not have the R, we do not have the radius, and again we do not have the slant height. All we have is the depth of it, which is the height of it. We don't have the slant height, we don't have the radius, we have the depth of it. But the thing is, for Pythagoras theorem, you at least need one more thing to find it. So we can't use the Pythagoras to find the slant height, but we can use the relationships of it, because when we look at it, this is your big one, and then the small one here is similar shape. So since it is a similar shape, we know we can use the ratio. So area of wet surface compare with the curved surface area of vessel will equals to the depth of the milk compare the height of the vessel. So this time is area, so the relationship between them is square. So area, and because you can only use this again because they are similar shape. So we let A be the unknown and the curved surface area of the vessel, you found it just now, and the depth of the milk is 6, which you got from part B. Remember, we're using part B, the depth, because the milk is, we add more milk now. And then the height of the vessel is 3 plus 6, and the whole thing square. So therefore, A, you should get 80 pi. But this is not the final answer. Why is that? Because we want to find the dry surface. So this dry surface, how do we find it? We find it by curved surface area minus the area of wet. So curved surface area 180 pi minus the wet surface area, which is 80 pi. So answer should be 100 pi cm square. We should keep this as the answer because it's set in terms of pi. So you can see that part B and part C, we use the ratio between the volume and the length, and the area and the length. And make sure you can only do this when the shapes are similar. You do not use this relationship between the volume and the length, or the area and the length, if the shapes are not similar. So if you got questions about this, you can ask in Edmodo. So please have a try